Well, good morning, everybody, and welcome to another edition of CGS Live, Houdini Special. I hope everybody's having a good weekend, or had a good weekend. It's Monday morning for me. This week, I'm thinking about getting stuck into a new project, and trying to just decide what that is. I haven't quite decided yet, but I have a cool spaceship model, so I thought I might try something interesting that a few people have been asking me about recently. Hey, Audrey. My camera is new as well. I gotta have yet another camera, but this one seems to be a little bit laggy. So I don't know. If that's annoying, let me know, because I still have my camera too, which is maybe not quite as nice, but I think there might be something wrong with my USB ports on my computer. They say they're USB 3, but maybe they're not. Anyway, so yeah, I thought, you know, that looking at the sort of long list of things that we have here. Hey, Zoe. Having a look at the long list of things that we have here, there was quite a few space type ones. Look at that camera budget, yeah. Time to Houdini with poo laptop. Well, yeah, I thought, you know, it could be an interesting one to look again at an effect that, you know, might seem complicated and work out ways that we could make it less, you know, less kind of intensive. And one of those is to create a kind of effect like a spaceship rising out of the water. So quite a few people have been asking me about this recently through the course, through CG Spectrum course. And I thought it could be a good one to kind of look at the different options. You know, the way that most people would approach it is to go about it by creating a large flip tank and having the spaceship rise out of that, but that can be really, really expensive and really sort of time consuming because of the simulation time needed for such a large area, and the detail is really hard to get. So I thought I might look at some other options for creating something like that, and maybe this is a project that we can kind of do over a few kind of weeks. So let's jump into Houdini, and I have to find my model because this is just an idea that I arrived at like 5 minutes ago. So I'm going to create an empty container, and I'm going to go and find my model. So bear with me while I do that. How is everybody? Everybody having a good weekend, I hope. Let's see if I can find this. How are you doing, Zoe? What have you been working on in Houdini on your laptop? Let's see. Spaceships. Found a nice sandwich place. That sounds good. I don't know if this is the one. Let's see. I have a couple of spaceships here. Well, this one's pretty cool. That might actually work quite nicely. Oh, cool. Completed your hotkey setup. What do you mean by that? I'm not too sure what you mean by that. Like you set up all your hotkeys in Houdini, is that what you mean? Cloth, cool. Using vellum for that? That's something that I'd like to kind of cover in one of my streams, is to go through some vellum stuff. Alright, so we've got this spaceship and hotkeys in Houdini, yeah. And we also have this one, which is like a much larger spaceship. Although, model-wise, it's actually smaller. But, you know, in terms of proportions, this one is like your giant kind of, I don't know, if you were thinking of it in Star Wars terms, I guess this would be a Star Destroyer or something stupid like that. This one has a lot of interesting details to it, which I think could work really well. But this one kind of has a bit more of an interesting shape. So maybe we'll go with this one. I'll leave this one off to the side. And so what I'm thinking for this is that it's going to be a shot where, you know, maybe it's an ocean. You know, we've all kind of seen those shots in like Avengers, or those, they tend to do it in Marvel movies. They have some giant ship coming out of the ocean, some big robot or something, Pacific Rim style. So, you know, something like that. Let's create an ocean surface. So we'll do an ocean spectrum and an ocean evaluate. Now, oceans are not something that I've had to do all that much in my career thus far, but we do teach them in our course. CJ Spectrum is part of the advanced course, so I have had to, you know, kind of get up to speed on how oceans work, and it's actually quite fun. You know, it's quite enjoyable to create these large kind of ocean scenes. And there's a lot you can do with it. You know, you can just create very static kind of things with no dynamics, but you can also create interaction and fully simulated oceans, and then blend those into the kind of rest of the ocean. Let's say, like, you might have a simulation, and then the rest of the ocean might be non-simulated. So there's ways of blending those two things together. But this is a very simple way of just getting going by creating a spectrum to create the data that you need to create the ocean, and then an ocean evaluate to represent that on a grid. So let's have a look at what we're going to do here. So I'm going to transform and just get this rising up. So let's have a look at our scale before I start. So we're sort of like, I don't know, what's this, between negative 15 and 10. So 25 meters. Yeah, I mean, that sort of sounds alright. Could be bigger, but I think that's a good scale to work with. Nice and manageable. So let's put it way down below the surface. And then I'm just going to merge these two things together. Stick my view flag on there. And transform it up over time. 25 meters, that's massive. Yeah, I guess. For a spaceship, it depends what's the scale. I assume, you know, I kind of assume that spaceships are really quite large, but it's all kind of relative, you know. Once you set it up, you can kind of make it look however you like by adding smaller details if you want it to look larger, or larger details if you want it to look smaller. So how fast should it move? Let's try 2 seconds to start with. So 1 to 48, so 24, this is 24 frames per second. So yeah, 24, 48 is 2 seconds. So we'll just rise it up. Something like that. You know, I think it should be pretty slow, so maybe 2 seconds is too fast. Now I've just bypassed the evaluate so that I can scrub this and it sort of goes a little bit faster. It's still pretty slow. You probably need to flipbook it. I could take this resolution down as well. That might help. There we go. So let's flipbook it, because you want to be able to tell kind of what the correct speed is. So I'll just do that. Definitely too fast, I think. Yes, definitely could proxy the geometry for speed. I think, you know, this isn't too bad really, but yeah, absolutely, you could. So yeah, that's too fast. I mean, yeah, we could just even do this as well, like put a box around your heavy carrier object, or whatever it is. Mine's called heavy carrier. Just put a box around it, and that will create a bound like that. And then we can just use that as our guide. So let's drag this. Yes, it probably would. Well, let's talk about that. So if you have a look at this ship, it's got a lot of really small components to it, which, you know, can potentially create a slowdown. So if we have a look at the count, you've got polygons, 579,000. So 500,000 polygons. And a lot of that would just be in this small detail. So one thing you could do is just like try and find the larger areas and select them manually. So, you know, you could go through like that, but it's quite tricky to do that with all these little bits everywhere. So what we could do is measure these pieces. So first thing I'm going to do is put down a connectivity SOP. Connectivity SOP is going to throw a class attribute, or assign a class attribute into the mix, and it's going to be based on the connectivity. So when I talk about connectivity, you know, this is one connected piece. So class attribute will be given for that. And then this is a connected piece, so it'll throw a different different class attribute. Or usually when you double click, that's a connected piece. So all those polygons are connected to each other. So that will get a class. Let's say it's class 2. Then this piece over here will get class 3, etc. So what we can do then is put down a measure SOP and measure per piece based on class. And you can see it there. So what we should see now, if we look at our geometry spreadsheet, we should see an area. You can see all these areas that are the same, and we could make it element type points, and then we'll get that area. There we go. So here you can see 2360, those two areas are the same. 2359, same. And we can see, we have a look at our range, we've got zeros. Hey David, how's it going? It's Daniel time. Don't tell me, David, that you're working on a ship rising out of the ocean too, because that would just be too much. Anyway, I hope you're doing well. So you can see we've got areas, a 0 area, that's weird. There must be some points in there or something that are just kind of floating around. And we've got up to 64 area value. So we've measured this now, and now we can blast. Don't tell me. We can blast based on area. So we could say area greater than, let's say, oh, actually less than, because we want to delete the small pieces. What are you working on, David? Always something interesting. So let's choose points, and look at that. Proxy ship. So we can dial this in. So we could say less than 50, we could say less than 2, less than 1. And you can see as we take that value down, we get more of those slightly larger pieces. So, you know, that would be a good kind of proxy, but you could take it further and just see at what point a lot of those smaller pieces come in. Yeah, let's go less than 5 to start with. And there's a nice proxy ship, and the box is a bit too hard to visualize what's going on. So now we've got this really light 5,000 polys ship that all the small pieces are gone, and we can just turn that off. Oh, okay, cool. It sounds exciting. Look forward to seeing that. Well, if there's anything that I can help you with, please feel free to shout out. So yeah, now we've got this nice simple proxy ship. So if you've ever got a model that's really complex, this sort of workflow of measuring based on connectivity and then just blasting away the really, you know, small stuff until you need it later on. We will need it. But for now, it's nice and quick. Just while I remember, I'm going to save this because it may, you know, crash. These things do happen. Just going to create a new file here, Spaceship Rising. Okay. So there we go. Now, let's make this. I already did make it 96, but I reckon let's go 120 and see what that feels like. Flip up. Oh. Well, it's very slow now. Boom. Great. Very uninspiring as well at the moment. And we could make it slower if we wanted to, but let's just go with that. It's easy to change. You can also make your animation curve, so shift click on your little parameter here that's animated, And you can see it's a Bezier, so it sort of starts out slow, then rises, and then slows down towards the end. So you could manually control these Beziers, or you could select your keyframes and just set it to linear. Incidentally, you can also change it here. Translate, you could change that to Bezier. Like that. And that, you can see, has set it back to being a Bezier. So that's kind of cool, you know. I don't really do that very often, but sometimes, if I can't be bothered opening up the animation editor. You missed it, sorry. Yes, the measure tool measures the area of each piece based on this connectivity attribute that I've created. And then I'm blasting the small area pieces away. So I can remove all the small things. And you can see, because you missed it, I'll drop the number down. You can see I can get them back, or I can just choose an area that works. So that one is 5K now, so that works really well. So, all right, we've got that. Let's turn our ocean back on. I'll leave my grid at the kind of, you know, larger scale just so we can see. So the scale of these waves maybe is a little crazy for this scale. I'm going for make procedurally. Hey, Abu, what do you mean make procedurally? Did I make the ship procedurally? Is that what you mean? So yeah, the scale of these waves is a little large for the size of the ship I'm going for. So let's go to the ocean spectrum, and yeah, I did not make this ship. This is a ship that was bought off CG Trader, I think. I might have a look and see who made it, so I can give them due credit. But yeah, this was a ship that we bought for another project, and I just have it lying around in my assets directory. It was probably made in Maya or 3D Studio Max, I'm guessing, based on you know, the way it looks. And that just is a pretty good, you know, that's usually what people model these types of things in. So it would be a cool thing to try and do in Houdini. That could be a challenge for another stream. So, you know, we've got to try and pick a camera angle as well. New camera, I'll just set one there. Might be an interesting camera angle. And let's go and ocean spectrum. Got our speed here on the wind, and that's kind of what drives the height of these waves. Well, it's one of the things. You can see taking that down produces a much calmer sort of ocean. Let's put our grid res back up just to help visualize kind of what sort of detail we have. So you can see there, got that kind of detail, and you can see there's a direction to this ocean as well. So you can see it sort of blowing from left to right. There is a directionality component to this wind here, so you can change the direction that those waves are traveling. You also have amplitude, so you have the ability to scale that as well. I don't know what sort of scale I should go for. I mean, maybe like, I kind of like it a bit larger, but I sort of want more details, so I can up the resolution exponent, and that will sort of give me much finer detail, which might work for the scale that I'm going for. You can also try playing around with the grid size to get basically more tiling from the grid size. So the more you take that down, so the more compressed it will become, and you can see finer detail, but it tiles a lot more. But there are ways around that too. So let's go 25, and then we can maybe take these down a little bit. You can see it's starting to look, you know, smaller or larger scale. The details are getting smaller, so the overall feeling is that the ocean is a lot, you know, kind of, or we're much further away, and the ship is a lot bigger. It's all kind of, you know, fake, this stuff, so it's just about trying to dial in the, you know, the way that it looks and the relative kind of scale between each of the components. So yeah, I think that's not too bad. Now, just because, you know, I'm very kind of like end goal oriented, and also very oriented, or very kind of you know, focused on ultimate look of this shot. It's all about how it looks at the end, not about how cool my simulation is. So I'm going to set up a little lighting environment as well, and check my camera angle and work all that stuff out before I dive too much into simulation land. Because, I just want to make sure that things are looking good, that the detail of my grid is looking good, and then we can kind of jump into simulations. Oh, look, it's not going to get too hard. Well, I mean, it may, depending on where you're at. No, we're not going into karma. Nah, I don't like karma. At least, not while it's in beta. I find it incredibly buggy and just very hard to use. So, no, I stay away from karma. So, what am I going to do? I'm going to look for a HDRI. Let's see. I have a whole bunch here. Let's do star.hdr. Let's see what I've got. Christmas photo studio. That's probably not going to work. Let's see. Abandoned slipway. Let's try that. As a sky. I'm just looking for ones with skies. So let's have a look at this. Yeah, I mean, that could work. I'm going to assign a principled shader to my water. And I'm going to make it not rough. I'm going to make it sort of, half reflectivity. I'm going to set my base color to black. And already we can see, it's starting to look a bit more like water. Might create a second principled shader for my ship and just give it a... Ooh, actually, they're the same object. So what I'm going to do is put a material node down on each. At the moment, I mean, this is not ultimately how I would do this, but just for visualization, let's do /matte/principled shader 1 for the water, and /matte/principled shader 2 for the ship. There we go. Yeah, I don't need normals. Let's just see how this looks. Jump out. Just call this water, and it's going through recalculating something. Let's jump to our render view. I'm going to hit save, just in case. Render. It'll auto-create me a mantra node when I do that. And off we go. So I'm just going to drop my pixel samples so it goes a little faster. In fact, I'll drop them to 1 so it goes very fast and it's very grainy, but that's cool. Yeah, that's all I need. Just want to see how it's looking. Detail-wise, I think I could probably get more detail out of my waves. They're a little soft feeling, but at the moment, this is just kind of a representation. Like I could crank up these rows and columns, but that's going to give me like a very heavy mesh. Ultimately, I'm going to do this through displacement, so I'm not overly concerned by that. But one thing I will do, just to make this a little easier to work with, because we are going to work on a much smaller kind of section of this water, is I'll take this down. So let's go 50. Oh, let's go 20 by 50. There we go. And we can see more detail now in that. So if I snapshot and render, we should be able to see that. And what else can we do? We can turn on our environment light geometry so that we can see our background in there as well. That can sometimes just help with visualization. So you can see there is a lot more detail in there when you shrink the grid down and get, more divisions sort of piled up. So there is actually a lot of detail there. I don't know, I'm not sure about the scale. I think it could probably... Let's see. So I'll just take some snapshots and go 15. Yeah, it's kind of interesting. Take the amplitude down. Houdini can do real-time render. I mean, this is not real-time. Is that, do you mean like what I'm doing is real-time, or Houdini can do it with Karma, but it is very beta at the moment, so yeah, I do not use it. But there are kind of GPU renderers out there. I wouldn't say they're real time though. There is a time factor, but they are faster than Mantra. But if you set your pixel samples really low, then your render times are very kind of short. So let's see, what else am I going to do? Take speed down. Just trying to get this a little flatter. We can always change this. Doesn't have to be this way. Let's go back to my material and just give this a little bluey green color, super dark. It'll just help with the look. Maybe a little lighter. There we go. So you can see I've got no refraction in this water, and really you don't really need it for this type of ocean shot. It's kind of not necessary, and it just makes your render really slow. So I think that's fine. We can play around a bit more with that much later. But let's now dive into the kind of effects sort of component. So let's have a look at this speed that we've got. I think it could probably be slower still. So let's stop this. Go back to our transform here. And let's just make it the full 240. You can see it actually doesn't start until kind of, what, 100, bit before 100. Let's actually make it so it does start around closer to 1. So, no, it can't, Abu. Houdini doesn't have that capability. Maybe in the future. Who knows? Who knows if that sort of stuff will come into Houdini, or whether it will stay in the kind of Unreal space and Houdini will just be the sort of power, the workhorse behind Unreal that allows for, crazy things to be done. All right, so there we go. So now we got it starting around 1, which is good. We don't have to wait 100 frames before our effects start. And we've got a much kind of longer duration of rising happening. So let's flipbook that and take a look. It's always important to check before you get started. Because if you do everything and then you flipbook at the end and go, oh man, that's crazy, it's way too fast. You got to go and change everything, which becomes much harder. But changing just your first keyframe is, not difficult. You can see it's much slower now, and I think that's, it's probably a good thing. So, I'm looking at this, so I'm imagining what the simulations are going to do. Water kind of running down this nice surface here. Of course, we have a lot more detail with these smaller pieces as well when I turn those back on. So, water running down those small pieces and dripping down to the water level into these channels, pouring off this kind of overhang surface here. This stuff, a lot of water sort of pouring down. So, hopefully everybody knows the type of effect, that you would have seen this type of effect in lots of different films. So I'm not going to look at reference for this, but yeah, that's the sort of stuff that I'm visualizing, and it is a good idea to look at reference. But I don't have my internet open while I do these streams, so it's a little bit challenging. But you can use your imagination to visualize how things are going to look, and then we'll add them in. So I think that's pretty good. It's very slow now, and maybe there should be a little bit more time before it starts. I think just having a little bit of a pause before something happens is good. It creates anticipation. But we had 100 frame pause, which is a little bit too long. So maybe I might try and get it started around 24 mark. So let's just shift our start frame a little bit. So there we go. It's a bit of a pause. And then it starts to rise up. Let's just see how that feels. "24. Abu, how many frames per second does VFX in movies use? 24. Yeah. So there we go. And 24 frames is good. I mean, it's fine for what you need for pre-rendered stuff. It's so you can see it's just a little bit of a delay now before the start. So yeah, 24 frames is fine, you know, and it's good. I get annoyed when, you know, somebody tells me that the project that they want me to work on is in 30 frames per second or 60 frames per second, because it's just more rendering time, more simulation time. But yeah, 24 frames per second is all you need. And sometimes even less, depending on the sort of project that you're working on. So let's take our ship. Let's go create a null here and say out ship. And I'm going to create out water. I'm going to create outwater proxy, maybe, or outwater surface. Something like that. And I'll probably take my grid res down because it's a little bit heavy at the moment. So we'll leave that there for visualization, and then we'll come out into a new container and start working on our I don't know, let's just call this like ship surfacing effects. And object merge. Go and find our nulls that we created, out ship. You can bring multiple objects with one object merge, so I could hit the plus and bring in another object here, but then they're in the one stream, so I usually just do it with two. So out ship and out water surface. There we go. And now we can start our effect. And actually what I might do with this water surface, just for while I'm setting this up, is I'm going to freeze it to the first frame so that it's not animating, and then it won't kind of, you know, take a long time to scrub or to cook pop simulations when I'm setting those up, or flip simulations. I'm just going to set my background to dark. And there we go. So you can see it's frozen. We've got our ship. Let's go back to our ship and turn off our blast, and we can actually copy this blast and put it in here if we need it, like that. So that we can always optimize inside of this node if we need to. So let's have a look. We've got this. And we've got this. The first thing I'm going to do is just see what happens when I do my old favorite first thing that I always do when I'm doing some effect, is I transfer color from one thing to the other. I mean, when I'm doing an effect where one object affects another, actually this one should be red, then this is the kind of, you know, the simplest way to get started, and it usually works pretty well. So to, from, and now I have color being transferred from my ship to my water surface. As it rises out, it will create this kind of red around where the ship is. So that can be really useful for, you know, sourcing some points on the surface of the water. So if we have a look, ship goes through, we've got blast on still. It's a little bit slow. Blast, our ship goes through, and then as it rises all the way up, you can see that that transfer stops. So this gives us a really good indication of where we can source points on the surface of this water. So as I said at the start, you know, the typical way of doing this would be to create a huge flip container and rise a ship out of it. But I'm trying to do this in a kind of light way, hopefully a way that Zoe can do on her poop laptop. Maybe, you know, it might be a bit of a push still, but it's an efficient way of working, and hopefully a way that we can really control and art direct the result. And that's always the goal for me, is to create something that I can really create a very specific look. And if somebody goes, well, I need this changed, or I need that changed, or I need more streams here or less streams there, then I can go, yep, no problem. But if you do it all in one big flip container, it becomes really challenging sometimes to direct that stuff, because it's just a massive simulation. It becomes much harder to control. So let's kind of see, and this is, you know, this kind of similar idea to the wave, in that, you know, we're doing these kind of sort of effects that, you know, sometimes would be a large container or a large simulation, but we're trying to do it with much smaller kind of stuff. So what could we do with this? We could scatter points on this grid like this. So we've got a whole bunch of points there. They're black because of the color. So we could crank that up. Turn off relax, because that's a very slow kind of operation. Something like that. Then we can transfer to those points. Now I'm doing it here instead of doing it here. I mean, I could do it here and scatter based on color. That could be a good way to do it as well. Although every frame you do get a different sort of point count, which actually maybe doesn't matter in this case. So I could do it there. And that gives me that ability to just scatter points exactly where I need them. Right at the start though, I've noticed when you do this sort of thing and you don't have any red, although it looks like we do have a bit of red there right at the start because of my distance that I've chosen. But what I've noticed is that if you don't have any, see that? If I don't have any red on there, it just seems to scatter points everywhere, which is a little bit annoying. So, yeah, I don't know why it does that, but it's a bit weird. So, you know, we could keep that distance kind of short if we wanted to. The blend gives us the ability to sort of have that fade out as well from the center, so that it's more dense in the center and it sort of peters off towards the edges. So that could be a good way to control some things as well. I'm going to go with something like that for starters. Whoops. So what I'm going to do with this is I'm going to create some velocity, and I'm going to feed this into a flip simulation. I've got my ship here, so I could trail that ship, create some velocity on it, and transfer that as well. So I might come down here, create a different one, and just transfer velocity to these points. Let's create a marker so we can see what that's yielding. V, vector, there we go. So you can see it's giving me this kind of upward velocity. Now, it's kind of, you know, it's just a very slow velocity, so arguably there's not really any need to do that. We know it's an upward velocity, but what I guess it would be useful for is if that ship was moving differently, or if it stopped halfway through the water and it slowed down, then that velocity would stop transferring. But because it is a very constant kind of thing, so you should be able to see, I guess maybe if we set it to forward difference, yeah, because it stops on the very last frame, and this is set to backwards difference. It's just this very linear velocity. So maybe that's a step we don't really need. But let's set the velocity on these instead, and just say v at v equals, open curly brackets, 0, 1, 0. And that's just going to create a vector straight up. So you can see at the end too, because we're outside of that transfer, they're all black, we get this weird scatter happening on all over, which is really kind of bizarre. All the way back here. There we go, just till right at the end there. So what I might do instead is scatter up here and then blast based on color. So like this, at cd, oops, at cd.x greater than, well, or less than 0.1, let's say, points, and that should delete any of those points that have a value of 0. So we should see now that these are all the red points. You could even make that like super close to 0, 0.001. But it should mean that right at the end we get nothing. No points. Alright, so now we've got this up vector. So let's feed this into a flip simulation. So I'm going to put down a dot network. And I'm going to put down a flip object, a flip solver, and a volume source. Particle fluid, get rid of that. That's the default cube that comes in. So we're going to source first context, source particles, don't have a particle group, delete it, and there they are. Let's give them also a color of white. So we have black particles, which will interfere with the visualization inside Flip. I'm also going to turn my guides to show particles. And I'm going to put a... I might do a pop force instead of the regular dot gravity, just so that it's much easier to see what's going on. So let's do negative 9.8. Hit play and see what happens. Got some points falling down. That's a good sign. Let's go flip solver, particle motion, turn off reseeding. Don't want that. Particle separation 0.1. Yeah, it should be okay. Let's see. It's pretty slow actually, so maybe 0.1 is a bit too high res for this scale. So let's go 0.5. Hit play. And, oh, there we go. So yeah, 0.5 maybe, like it's quite high particle separation, so you can see them all kind of glooping together like that. But we got flip. So it doesn't look very interesting, and it's kind of not really what we want at the moment. But what we are going to do is put down... I'm going to do a ground plane for starters, because that's like... It's going to be in the same position as my ocean. And it's just going to be a nice efficient collider. So, you know, you can see our oceans at world 0. Have a look, it's at world 0. So the ground plane's just going to be a kind of proxy version of that. Let's look through our camera. And hit play. So these particles should come out and then just slide along the surface. Cool. Okay. So it's working. It's not very good yet. This is erroring. I don't know why. Probably just because I hit escape. What are we going to do? We're going to go out. We've got a very kind of sparse amount of points. So let's change that. We've got our scatter here. Only 7,000 points on there, so let's go and crank that right up so that we end up with a kind of much denser amount. Our velocity is really small, just 1. So let's crank that up to 10 and see what happens. Reset. There we go. Hit play. There we go, so we can see we're getting particles shooting up. Now, they're really kind of sticking together and looking a bit kind of gloopy, and I think that's just down to the low particle separation. So let's take that to 0.1. Let's just make sure that we don't have any weird attributes on there. So we've got, yeah, just V, hit play. Pretty slow, this, and I can see down here that this is sticking on a blast node, blast 1, and that's our area blast that we're doing. So what I'm going to do here is, let's have a look at that. You can see this, you know, it's not super nice to scrub, this one. So I'm actually just going to put a file cache down. And I'm going to write this to disk. So I'm going to say $os/ and This drive as well that we're on is not a solid state drive, so that could be part of the problem. Let me have a look and see if I have any space. It is unfortunately the drive that has the most space, so I think I will have to stick to this one. As you can see, I'm all red. I need to free up some space, but this one has 112 gig, so that should hopefully last another hour. So let's call this Proxy Rising. And I will write that to disk. So, I mean, that's always a good indication when you're simulating and it's going slowly. Have a look down here and see where that kind of slowdown might be. Because it's possible that something that you're doing outside that is slowing your simulation, not necessarily your simulation settings. Or like try turning off colliders or things like that and see, you know, if it goes a lot faster to try and isolate the problem. Performance monitor as well is something that I use all the time for figuring out why something is slow when it shouldn't really be. It doesn't seem like it should be. I use the performance monitor. So if you're not familiar with that, I'll give you a quick look at that when this is finished caching. But that will show you exactly where your slow components are. And it's disappointing when it shows you that your simulation is the slowest part, because it's like, well, there's not much you can do. But quite often it will show you, you know, slow nodes in SOPs somewhere else in your network that's slowing things down. So that can be a really good thing to kind of, yeah, check. It's almost done. Let's have a look. There we go. So I'll have a look at that. Load from disk. There we go. Scrubbing nicely. Let's have a look at our simulation. Oh, look at that. Like a dream. So that was a really, really slow node. So performance monitor though, if I turn that off, bypass it, have a look at my performance monitor in here, hit record and hit play. And this will go through, and look at that. It's already highlighting that blast as being a really slow node. So it shows you based on speed, based on time that it takes to cook each node as this is evaluating, where your slowness is. So you can see right at the top is that blast one, and then below that is the .NET. So the flip solver is the next slowest thing, and then everything else is, you know, really, really quite quick. But this is huge. 16 seconds just to solve that. It's accumulated, but compared to the .NET at 0.8, that's a massive kind of, you know, time sink. If you go out as well, it colors the nodes that are quick and the nodes that are slow. So you can quickly go to it and go, well, yeah, I'm going to do something about that. So just hit stop. If you want that to go away, you can just hit record again and stop, and it clears it. It also clears those colors. But now we'll turn this on. And yeah, we can see now that it's nice and fast. Oh, what's going on here? What did I do? Did something bad. Oh, that's interesting. Oh, the error is being caused by this load from file report error, no geometry. There we go. I don't know what happened to my simulation. There we go. All right. So we can see now we've got that 10. It's squirting up quite a lot, so it's probably a little bit too aggressive. But you can start to see now that, you know, we're getting an interesting effect where we're getting this stuff kind of shooting out and splashing across what will be the water surface. So we get that. And if you have a good imagination, you could imagine that this is like the kind of whitewater interaction or bubbles or spray coming from this ship surfacing, pushing, displacing water and creating lots of turbulence and interesting stuff. It's a bit weird the way it's squirting out right at the start, so we need to do something about that. I don't think we should actually have water at the start there. So probably, let's have a look at our transfer here. We've got our attribute transfer, and it's transferring actually before the ship comes through. So let's turn that down. Do something like that. We could also animate this up over time. Or we could also, you know, go to our transform. I'm not going to do that because it means writing it out again. But we could go down to our transform and actually just add some keyframes right at the start there. Oh, actually, is it? Oh, no. That stuff actually we've blasted out. So that's interesting. I should move that down more anyway, because that should be below the water. So let's try that. We got now. Yeah, so we're going to need to cache that out again, unfortunately. So let's go like down to negative 3.6. What's going on with that keyframe there? It's a bit of a weird key. Linear. There we go. So that's a bit too quick. Let's drop it up a little bit. Go to my front view. Something like that. Maybe drop this down a little bit. You know what? I'll just drop this one down, and then we don't have to worry about that. There we go. All right. So we're going to cache that out again, which is annoying, but it will be worth it. Save to file, save to disk. I've used this technique quite a few times for doing surfacing type effects. By surfacing, I mean, you know, things surfacing in the ocean. So yeah, I think it's a really good kind of efficient way of doing this, and it works surprisingly well. Hey Robert, how's it going? I am making a ship surfacing out of the ocean effect, a la all those movies that you love. I don't know, you could tell me. I'd think Avengers, but I don't know, it's in lots of movies, and you would be better to tell me which ones it's in, because you've seen them all. But it seems to be in a lot of these kind of, you know, Avengers style movies these days, because it looks cool. It looks really cool. It's often Scanline VFX that do these, because they have pipelines set up for these kind of massive ocean shots. But yeah, you know, it's a really cool effect. And it's even cooler if you can do it, you know, in a way that allows you to really art direct it and get it done on, you know, your home computer. So yeah, Pacific Rim, or, you know, I'm thinking, I think it's Avengers, the one I'm thinking of, but I'm sure it's in like tons of movies where a big kind of spaceship comes out of the water. So let's have a look at our points. There we go. So we're not getting points actually until a bit later. There we go. So let's have a look at that. Around there. We could play with that now. Alright, let's see what that looks like. Reset. Yeah, so a bit later, but... And you can see the velocity is a bit crazy, but now at least it's not starting until we get, you know, the ship coming through. Okay, so let's turn that down. Too crazy. Let's go 4. And I'm actually going to take this now, have a look at these points, and put a particle velocity node down. What's it called? Point velocity. Can't type. There it is, point velocity. And we've got some crazy stuff happening because it's set to compute from deformation, so we'll do keep incoming. Or we could set value on here as well. You know, could just ditch that and do this one. Might be a bit easier, keep it in one node. And then I like to use this conical noise on here because it gives you this kind of cone angle and scale. So you can sort of create this fanned effect, which is pretty cool. You've got a seed as well, so you can change the seed. And then you could combine that with this. And also curl noise to create a nice kind of splashy effect. So let's see what that looks like when we run it through the sim. Spiky. There we go. So curl noise is probably a little too large scale, so the frequency is too low. But you can see now we're not getting the crazy kind of shooting out stuff, but we're getting this nice kind of splashing effect. Maybe we're not getting enough height now. So I'll take the swirl size down. I think it's always hard to remember what setting that is. So let's see, swirl size, yeah, larger is low frequency. Swirl size down, high frequency. Let's crank this up a little more. And run that. There we go. It's looking interesting. All right, now we've got this like really sort of large spread going on. So I want to calm that down because it looks a bit weird, like it's shooting across the floor. We have this ground plane with the physical tabs. We also have the physical friction scale on our physical tab of our flip object. We also have volume motion collision. So to get friction working on these two things, we need to, on the flip solver under particle motion, under behavior, turn on use friction and bounce. And that will enable those sort of physical parameters to be used. But I'm going to use collisions, stick on collision. And let's see how that affects the performance. Hopefully they won't spread out anywhere near as much, and I think we can all see that it's now just sort of sitting on the surface. It's spreading, but it's not shooting across the surface. And it's sort of clumping together a little more, which is kind of cool because this is meant to be sort of foam or white water on the surface. There we go. So that's kind of cool. Now, let's turn on surface tension as well and see how that affects. I can just play it from this point and see what the surface tension does. We'll see how that affects the kind of look of this stuff specifically. I'm interested in just trying to get that to sort of clump together in a surface tension-y kind of way. Might have to go back to the start. There we go. Getting some kind of shapes in there, which the surface tension is going to sort of pull things together. So, you know, hopefully we'll get some interesting shapes. We could also have a look at, I showed you that kind of fake foam technique for the wave a few weeks back. And we could also look at trying to apply something like that in here to this simulation, to these points, to get them to create those interesting sort of strand shapes, kind of like a Voronoi fracture type pattern. We could try and actually apply that to these, which I've never done, but it would be an interesting thing to try. So you can see we've got a cool kind of simulation happening, and we don't have an ocean at the moment. It's just like points kind of being shot out based on, this transfer. Now, a thing that's going to make this kind of cooler is if we bring a collision in of our ship. So let's create that first. We'll go out here from our proxy. We'll create a null. Call that out collision geo. We've already got our trail on there, which is good. And over here, we'll do a VDB from polygons. Same thing we always do for these collisions. Might go voxel size a little smaller, and I'll call this out collision VDB. And just scrub it, looks pretty good. Let's go static object, merge, out collision geo, use deforming. We can turn on reevaluate, although, We don't have any substeps yet, but may as well turn it on. Use object transform is not important. That is to do with this transform only. It's not to do with anything inside here. No, not to do with transform nodes or anything like that. It's only to do with top level transformations. Collisions, we're going to use the RBD solver volume, volume sample, and then proxy volume. At collision VDB. You can double check it if you want to. Looks good. But really, it's important to check the guide for collision to make sure that Flip is recognizing that as a collision and it looks good. So let's hit play on that. Should see this update as it comes into, as those particles start emitting. There we go. It actually looks a bit weird, and that is probably the ground plane there. So what we're seeing, this box is the ground plane, and below it is just collision. But we should start to see that update above. There we go. You can see it's sort of that collision field showing that ship rising through the ground plane there. All right, so let's play it. Let's see what happens. You could always not have the ground plane as well. So you could have these just falling down, running off the ship, falling down, and then getting deleted when they hit the bottom of the flip container. That could be a way of kind of dealing with it as well, and also keeping it really light. You won't get that spreading across the surface effect, but it will be a nice kind of splash and then come down and just die. So what we're seeing now, which is what I was hoping to see, is we're getting particles running across the surface of the ship. So let's have a look. You can see now we're getting this nice kind of cool effect of particles running down the surface as that rises up. So we'll hit play. And what's cool as well is that we've got all these particles here just sitting on the surface, sitting on that ground plane. And as the rest of the ship comes up, it's going to catch those and pull them along with it, which is awesome. So already this has made a massive difference. And you can see so far, you know, we're not crazy sim times. It's gone over 5 gig in terms of the amount of data that we're storing. So the tail of this simulation is starting to disappear as it adds more frames. So we could change that if we wanted to. We could go out and add more to our simulation cache. You can see it's got a limit of 5 gig, 5,000 meg. But we'll just leave it. That's okay. We'll cache it to disk probably. I just want to see what it looks like right at the end here. We could also add variants to these effects as well, so that they're not just all splashing, you know, like crazy. Maybe it does that right at the start, and then overall it calms down. Or we could, you know, we could vary it across the ship so that some parts do it and some parts don't. Might be kind of cool, so that it's not all just like popcorn. Here we go. We can see the wings of the ship now kind of rising out and catching that water that was already on the surface. Plus it will have created its own water as it was coming through. You can see those white sections are where the new velocities are being added. So we've got that kind of bubbling effect going on. Let's look through our camera. I feel like a lower camera might be kind of cool as well. You can have a few different ones, so maybe some animated camera. You can see the duration of the timeline is the sort of size of it is getting smaller, and it's because we're getting more points added all the time that this 5 gigabyte actually shrinks. It's sort of, you know, now it's much less frames that take up 5 gig of that memory. So we're getting less down here. But hopefully right at the end. One thing I'm going to do too, before it gets to the very end, is I'm going to flick my play behavior to play once. Because what will happen with this set to loop, which is the default, is once it gets to the end, it'll go all the way back to frame 1 and I'll lose my cache. So I always do this when I remember, to set it to play once, and then it will hold at the last frame, and then I can just scrub my last frames so that I can see you know, that last little bit that I've got in my viewport cache. It's really annoying when it loops and then you have to wait all over again to see something that you were trying to catch right at the end. So there we go. 240, done. So you can see we've got some really nice kind of stuff happening. Nice details there. There's a nice kind of symmetrical shape that's happening there because of this model being symmetrical. Look at that. Beautiful. Flip is very satisfying to work with because it just looks nice. Alright, so let's have a look from the top. Okay. Not bad. It's very kind of uniform, but this is on a ground plane which has no surface detail to it at all, so we are going to bring in our ocean surface eventually. But I like what's happening there. Adding that collision in has really kind of, you know, really kind of helped a lot. But one thing I also want to do is source my own particles, because, you know, maybe the director goes, well, I really want to see things streaming off the entire time all over the ship, not just based on what the ship drags up, but I really want to see these fine drips. So I might think about doing those in pops first of all and see what that looks like, and then if it needs to be more fluid feeling, maybe then we'll come back and do it in flip. But I think the first thing that we should do is turn off our proxy ship and our blast, and let's see how quickly this scrubs. It's actually not too bad. So the blast is actually really quite slow. Let's have a look at our VDB. That doesn't look too bad. It's a little bit slower. We might need to cache that out. That could be a good thing to cache out. We could run our performance monitor again. But let's go and have a look at this. So we've got our... looks like we're just catching that one there right at the start. Okay, let's have a look. Hit play, see how slow it is. It's a little bit slow, so let's have a look at our performance monitor. Hit play again. VDB from polygons. So you see, it's a really good way of just going, where's that slow point? All right, let's cache it to disk. While we're caching it to disk, we may as well make it a little bit higher resolution, although it is pretty high. Let's see how many polys we have here. Oh, how many voxels? We only have 1.5 million, so let's go 0.025. I think it's just all the detail, you know. It's a lot of detail there. Let's try that. Turn off my performance monitor. Oh, it is off. Just duplicate my file cache here. This is going to be a little bit slow. How's everybody doing out there? Still there? High res, VDB, collision. And save. See how long this takes. It's going to be slow. For all the CG Spectrum people, students that are joining us, hopefully you will have seen that we introduced a new kind of competition. I wouldn't say it's a competition, really. I don't know what to call it. Collaborative project. There we go. So we launched a collaborative project, which is going to be over 12 weeks. It's going to be taken by me, so I'm going to sort of run it like a studio. So, you know, we'll have a task or a large shot that we have to work on, and there'll be a whole bunch of tasks created depending on what's needed for the shot. and they'll be assigned to the people that kind of take part. So it's an application process. You have to apply to be part of it. But yeah, hopefully, it'll be a really cool project, really cool kind of result, but also a good experience for people that haven't sort of taken part in something like that, haven't worked in a studio before, and just a way to kind of build your skills and build your confidence in working with a team, and just sort of finding out a little bit about how productions are run. 12 weeks is quite a long time to do, one shot really. So hopefully it won't be too crazy, the pace. But I hope everybody, who is in CG Spectrum anyway. I'm sorry for the people that aren't, who are watching this. But yeah, I hope you do apply and try to get into the program, because it will be a really cool kind of experience, and I'm looking forward to it. And yeah, it's should be fun. Who knows what will happen? It's the first one, but I think it'll be a lot of fun. So you should apply. This is taking ages, but it'll be good once it's done, because then it'll make the simulation a lot faster. Hopefully back to what we had. Yeah, I think, we are trying to do more of these collaborative projects at CG Spectrum, so this is the first one, but hopefully there'll be, at least once a year or twice a year, I don't know. This one is also cross-collaborative with the compositing department as well, so hopefully we'll get some compositing students and we can all work together, as would be in a real-life situation in a studio. You would be working with many other departments. So hopefully that's the goal, is that we create a kind of, collaborative project that involves everyone. Modeling, animation, VFX, concept art as well. That would be really, really cool. But I imagine that would be much harder to manage. But one day we will get there. 77 of 240. It's like watching paint dry. If only I had a render farm. I do have a second machine here that I've been thinking about setting up as a rendering machine. That would be quite handy. It's eating up our valuable stream time here. More fun than watching paint dry. Yeah, it's funny. Like, I don't know. My computer at work at Method, when I used to be there, the screen would kind of would freeze while you were doing this. So you could kind of paint with this progress bar. So like it would print the, like, every time you moved it, it would leave a trail. So frequently I would just be sitting there kind of making these like arches and little mountains and things with this progress bar. And it was quite satisfying. Or like if you ever played Solitaire on the computer, when you complete it and the cards like bounce around and leave the trail behind them, I would just do that and think about Solitaire, which is sad. But yeah, that was kind of fun. I don't know why I did that. It might be something to do with Linux. We're almost there. Well, we're halfway there. I can stop it. Let's stop it. Don't want to wait for that. As always, I will do this. I will cache this stuff out during the week. Oh, I just remembered. I'll have to show you guys before I finish up today, the render that I did for my acid that I made last week. I think that ended up looking pretty cool. And I made it loop as well, which was kind of fun. So let's hit play on this and see how fast or slow it is. Let me make sure I turned on load from disk. Yes, I did. And what have we got here? We've got 111 frames. So what I might do is just put a switch in and say, I'm going to say $F greater than 110. And then it'll switch to the non-cache version at 110 or 111. So at least it will continue and not error. Let's see what happens. It's much faster, which is good. But yeah, it shouldn't really be bubbling up so much right at the start. Might have to animate that velocity up or down. Up and down. Maybe. So we're going to get to about here before it starts really chugging and going slow again. But hopefully that will be enough time to see some really interesting kind of details with this flip. Yeah, now that we've got all this detail on the ship, there's a lot of areas for it to kind of get caught, create little rivulets running through, and some interesting details. This is crazy. Like, these are just antennas transferring this nuts velocity here. So things like that need to be kind of worked out. And, you know, we need to kind of work out maybe a way. Maybe the velocity is only on the kind of broader sections of the ship, and the smaller sections we can work out a way to kind of not have so much velocity in those areas. I don't know. We could do that based on that measurement as well, perhaps. All right, so it's going along. You can see our cache bar now. It's much smaller as well. Let's have a look at our collisions, because even though we have such a high-res VDB that I wrote out, our collisions are still only going to be, in fact, they're going to be 2 times 0.1, so they're going to be at 0.2 scale, because this grid scale determines the scale of the volumes in the simulation, so they're actually 2 times the scale of the particle separation. So if you have a look at the collision guide, it's actually going to be much more low resolution than what the collision is. One thing we could do there is actually just add a little offset, and that probably won't be apparent until we go back to the first frame. So we have to run the simulation again to see that change. But adding a little offset can help to the volume to just inflate it a little bit. But also, probably we need to reduce our particle separation to get our collision down. We could also take the grid scale down, but usually it's good to leave it at 2. It's better to take the particle separation down, increase the resolution overall. Now hopefully we'll see a little bit more detail. You can see this section here, it's very thin, so it's kind of coming and going, and that's what the offset surface will sort of help with. It will inflate those smaller details a little bit. So, you know, we may want to just go back and try and do that a little more. You don't want to do it too much because it can overinflate things and they become too big. So there's a line. But it's good thing to try. Let's see what happens now. Still sort of coming and going a little bit. And to check to see if it's overinflated too much, we'll just turn this back on. And you can kind of see, you know, it's sort of still basically sitting in the same spot, so that's okay. These are very thin, so we might need more resolution in our VDB. But we'll let it go. Oops, didn't want to do that. Okay, let's turn this off. Actually, I'll leave that on because I want to see what it looks like a little bit further on the surface of that ship. So this probably is going to be too much for your laptop, Zoe. I'm sure your laptop would have caught fire, you know, half an hour ago. But I will show you. I don't know if I'll get time in this stream, but I will show you some other kind of ways of approaching it as well. using particles to add streams and other things running off the surface of this ship. And it'll be something that'll be useful for this as well with the flip. The flip will be like an underlying fluid thing, but then we could also try and do it. We could try and do the whole thing with particles and just see how that looks. Probably won't give the same kind of fluidy result, but it still potentially could look cool. There are many different ways to do this sort of stuff. Yeah, this kind of flickering doesn't fill me with great confidence of this collision shape, but maybe more offset could be useful. I'm just going to let it go. Let's turn our particles back on, see what they're doing. Going crazy. We've got a much higher particle a higher particle separation now, so we're going to get more points as well. Yeah, that velocity is just a little bit too crazy. Oh well, let it go. Let me find this. Let me find this acid while that's running that we did last week. Stream render. Here it is in all its GIF glory. I actually ended up rendering this in Redshift, only because it was taking really long time to get a nice render out of Mantra. So I thought, well, I may as well just bite the bullet and set it up again in Redshift. And I set it up to loop, which is kind of fun. Basically all I'm doing at the end there is just transforming everything up. I linked it all to a null at the viewport, and I'm transforming everything up, and I created a second plane of metal with the same texture on it to come up. So it sits below, and as I transform everything up, that one just comes to the sort of same position. Basically, I took what the high position of the null was when I transformed everything up, and I just subtracted that value from the second ground plane, so that it ends up being at the same location as the first one. And then you get this looping effect, which is kind of cool. So yeah, I think it turned out kind of nice. It's a fun little simulation, fun little kind of looping stuff is quite satisfying. It's gonna be tricky, but that one ended up not being too bad. It took me a while to kind of match the lighting that I had in Mantra and Redshift. Sort of, it's a bit hard to kind of get the same lighting, but I ended up getting there, I think. What would be cool for looping would be to like get the result of this simulation, so that as the fluid shape that drips down from the end becomes what drips down to the next one, rather than it going back to being this just single gloop. So that would be an interesting challenge to kind of work out how to make that end point the starting point, and then get that to loop. So yeah. All right, so can't quite see the detail yet on this thing. This one we're kind of seeing, we're not really seeing any, there's a little bit of fluid caught there, but it's not really sitting on the surface either. So overall, I think we need much higher resolution with our collision, but it's okay. Keep going. Press on. So slow. I just saw that there's weather on my on my start bar now, and it says 6 degrees and sunny, which sounds incredibly cold. That's 6 degrees Celsius for all of you North American watchers. But yeah, that sounds a bit freezing. Glad I'm not outside right now. So yeah, this is taking ages. I'm getting impatient. Let me just have a look at my collision here. You can see, I'm starting to see some of that finer detail, but it's still pretty blobby. So it is going to require, you know, a lot more detail to get all those shapes. So let's have a look at, you know, alternatives for this. So we're going to use this, but we're also going to use something else. So we've got our ship here. We've got our transfer. So that's good. That part I think is looking pretty good. I think the velocity needs to come down. It's 6, maybe it could be 3. Yeah, maybe I'll just change that 3. So that simulation I will run. You know, it'll take however long it takes, an hour or so. Now let's have a look at what we could do with just particles. So we've got our ship. Let's do a scatter on the ship. Even just that is fine. I do not want these particles to jump around like this every frame. So what I'm going to do is time shift those to frame 1 and turn on output attributes source prim and source prim UV, and then put an attribute interpolate down, and this will match up the source prim and source prim UV from the points when you scattered them on the static object to the source prim, or to the primitive, to the same primitive on the animated object, so that down here what we get is a constant scatter. So that's awesome. It's nice and quick, but now we've got points that are in the same spot every frame, apart from the translating. Let's put that into a pop network, and we'll do source points, pop force, -9.8, and we're going to want our static object. So we can just copy that static object from there into here. No, that's not the one I want. It's weird. Copy buffer sometimes is a bit slow in Houdini, so just hit Control C a whole bunch of times. There we go. Okie dokie. Let's see now what happens. I mean, let's just turn this off for starters, and we get raining particles. Wonderful. Let's turn on our static object, and it's going to be slow, but we'll get raining particles, and you know, they're going to be hitting the surface, hopefully. It's a little bit hard to see because they're red, so let's color them white. They have the velocity of the ship on them, so that's okay. It's not a very strong velocity, so they're not going to really shoot up, but they might just shoot up a little bit, which might help them get away from the surface of the ship. But we can see they are kind of raining down and sliding over the ship's surface, which is good. Now, I don't really want this effect to start until they're above the water surface. So I'm going to, what am I going to do? I'm going to put a pop kill down. And actually, no, I'm going to do it out here. So I'm just going to use a wrangle, and I'm going to say at, or if at p.y is less than 0, remove point. 0 for the first input, at pt_num, so that it matches that across all point numbers. And there we go. So now you can see that I only get points above 0. So they only appear once they're above that level. Run the popnet. Collision object's a little slow, so probably you should just start the popnet from frame 20 or something, but now we can see that we only get those particles starting once they're above the surface. We could put a ground plane in as well for them to collide on the surface, or replace that with our collision, our ocean collision, which we haven't done yet. But we can see we're getting these nice kind of waterfall effects happening, which is really cool. And it's pretty quick. We're already at 89. We don't need them to fall forever, so we could use a pop kill, or we could drive that via age. Let's use a pop kill actually, and we'll do it based on rule. And we'll say, oh, let's choose kill by condition. There we go. Dead equals p.y greater than 1. Let's do less than -2. See what that evaluates to on the second frame. There we go. So our water surface is here, and I'm just killing them below that water surface. So I could really kill them at 0, or I could kill them at -1. And that way we don't end up with a ton of points just falling off into infinity. But we do get them sort of falling below the water surface and then dying eventually when they're out of view. And there's our ship flicking over to the non-cached VDB. So it's much slower. So there we go. That's cool. And what is great about this is that we can control where these points are going to be, how many of them are getting emitted, what rate they're getting emitted at. So at the moment, they're just sort of, you can see it's quite a steppy stream from these things. So we've got, let's just double check and make sure that our ship is actually properly interpolating. Go to our global animation options, turn off integer frame values, set our step to 0.1, and then just step through. And you can see as I'm stepping through, I'm at like 39, 39.1, 0.2, 0.3, 0.4, and our ship is, and as I scrub as well, I can see that our ship is properly interpolating between those integer frames. If it wasn't, it would look something like this. If I put a time shift down, the time shift by default will convert things to integer frames. So you can see now, as I step through, it doesn't interpolate and it jumps every frame. So as I step through, it's not interpolating correctly. You can see the difference. Nice and smooth. So that's good. That's what we want. So when we turn on substeps, we know that our collision object and our source is going to interpolate properly. Turn that off, integer frames back on, popnet, subsolver. Let's increase the substeps. What we should see is that we get streams that are closer together, much tighter, more sort of points in that line, hopefully. Collision's doing some wacky things to this point. These streams are a bit kind of broken. Let's have a look at this one when it comes through. It's a little better. So if we come back to here, it's 49, and let's do like 6 and 6. Just to see what that looks like. Yeah, so I think what's happening here is that the collision from this point is sort of causing it to do that. It could also be the velocity, so let's turn the velocity off. Looks like this is resolving, so let's just set my start frame here to be 50. Okay. So if I go back here and turn my static object off and see what these behave like, you can see they just fall straight down. So the collision is what's causing that to kind of bounce off. You can see still there's not a perfect stream here, so they are separating as they fall down. And we could try increasing the rate of our points here. Or we could just do impulse as well. Set it to points, all points. And then it will just use impulse. And then that might give us a nice, there we go. So that's a nice tighter stream. Turn our static object back on, and we should still see that kind of broken stream, but it might be better now. You can see that kind of weird stepping that we're getting. So it's the collision object forcing it out a little bit and then dropping. So there's not loads we could do about that. I mean, well, there are things we can do. We could try bounce, but we might actually have to change our source, I guess is what I mean. There's not loads in here we can do, but we can try changing some of these settings, like the bounce, and see if that has any impact. Turn that just down. Oh, it's a little better. We're not getting things thrown out quite as far. The thing that we might want to do is just maybe peak the surface of our ship slightly before we scatter. It's a very small amount. You can see it's screwing up the normals, but that's okay. We can turn that off actually. Just a small amount, but that will push the point off the surface. You can see it's just changing the location of those points slightly. It'll just push it off the surface a little bit. It's also changing where our points are scattered, unfortunately. I mean, we could do the peak actually after the scatter. And that should, let's see, maybe our scatter is not picking up normals. No, it is. Oh yeah, very small. There we go. So that's just going to move it away from the surface a little bit. So we set that to 0. Let's time shift. There we go. So let's have a look at that peak now. So doing it after the scatter doesn't change the result of the scatter. So there we go. It's off the surface now. So hopefully when we do that, we might not get as much of that kind of push that's happening. Still doing it a little bit. Maybe it's better. I don't know. It's hard to tell. Anyway, doesn't matter. You can also try playing with like the jitter time, the interpolate source forwards or backwards, and see if the interpolation can kind of help with that stuff as well. Can sometimes help. Let's try forwards. It's not a massive deal. It's not too bad. Let's have a look down here. See what these look like. We've turned bounce off now as well, and it'd be interesting to see with having low bounce settings whether that kind of I think that jitter actually, let me turn that off, the interpolate often kind of doesn't do great things. So yeah, it'd be interesting to see what happens with the bounce off with the particles that run down the surface, whether that's a nice, keeps those streams a little bit nicer maybe. Let's see. You could also actually do this. It might be better to do this on a static ship and then transform the whole effect afterwards. So go back to frame 1. And it might make it more difficult to do this stuff, actually, doing that. But it's worth a shot, and it actually might end up being a much faster effect if we were to take... So let's go and freeze our collision geo. This will affect our flip, so we should create 2 separate ones here. But I'm going to create time shift on both of these. And then do a pop sim. So this one, we don't actually need the attribute interpolate either, because it's just a static thing now. And now we don't actually have an animated surface. So we can turn off use deforming. Let's turn off our pop kill, and we'll just hit play. Let's go from frame 1. And you can see that's quite quick, although it doesn't seem to be colliding. So let's see what is going on there. Turn that on. Sometimes when you have really high VDB count, that can be really slow to turn on, so just be careful with that. Turn it off, display geometry. Yeah, it's kind of weird. It doesn't seem to be colliding now. Let's just make sure. It's got our points there, got our peak, time shift, time shift, time shift. Frame 1. What? Well, that's weird. Why is it doing this? Why is it doing this? Bypass the attribute interpolate. Oh joy. Use deforming geometry. No. RBD solver. Volume sample. Out collision VDB. Have I done something wrong here? No. Collision geo. What? Peak. Well, that's weird. Maybe I'll turn this offset off. Huh. Okay. Let's delete this static object and bring it in again. Out collision geo. I'm just gonna leave it at ray intersect and see if the ray intersect method of collision does anything, and it doesn't. What is going on here? Use deforming geometry? Let's turn that on. You can see, it makes it really slow to turn that on because it's updating at every frame. But so far I can't see that it's made any difference. No. Well, what is going on? Let's set the substicks back down to 1 and 1. Negative 9.8. Popnet. Bounce 0. I mean, we can try just resetting this stuff. That one's normal. Oh, look at that. We got some bounces going. It's weird, isn't it? I don't know why. I don't know why that's doing that. It's very odd. You know what? I mean, we do have a velocity attribute on here, but it is 0 at this time. I'm going to do two things here. I'm going to put a facet node down on my geometry. Pre-compute. Let's try that first, actually. See if it makes any difference. Well, there's definitely some collisions going on there. But not a lot. I would have expected some more collisions to occur. Like this one, for example, is just kind of falling down, and it's really hard to tell, but it looks like it's going through. Yeah, it is just going through. So that's kind of lame. Let's set it back to volume sample. Or we could also try surface collision. Might be interesting. That's probably not a good idea to turn that on. Let's try surface. Yeah, it's the same. Alright. Oh, actually, I need to do this. Flick it over to surface. It's probably going to be really slow, actually. But it would be interesting to see. Yeah, that's intolerably slow, so I'm not going to use that. Let's go back to volume sample. Hey, make something. Thank you. Thanks for joining us. Yeah, let's hit play. Oh, there we go. Maybe the offset surface I had. I swear I set that back to 0, but I don't know. Sometimes weird things go on. I did copy this static object from the flip solver, so maybe some crazy things, you know, kind of happening. But you can see this is really fast now, which is great. That's the goal. So what am I going to do? I'm going to set my life on these to be 1. Let's go 0.25. Oh, well, that's too short. 0.5. Still too short. I guess 1 was not too bad. Should be looking at these ones, really. These ones running down the surface. So actually, maybe my life expectancy should be more, and I'll just use my pop kill to kill ones that are below. Let's see, below 5. Below -5. And that way, we won't get them falling forever. Let's do -6, bit more, because this area here is at -5. There we go. But really, I mean, all we're concerned with is this kind of effect of these particles sort of running over the surface at the moment. So that's kind of cool. Interesting thing happening here. I suspect what's going on, well, I don't know what's going on exactly there, but it looks like maybe there's a particle that's just kind of sitting right in there and intersecting. Have we got our peak on? We do. Let's try increasing this peak a little bit. 0.009. Reset. No, still happening a little bit. Let's turn these down again. Get no bounce. So the bounce really seems to be important. Well, let's try bounce forward, leaving that set to 1. And let's set the bounce to 0. There we go. Alright, so bounce forward. Not good at 0. Now you do have this ability on the pop solver, collision behavior, add hit attributes, response, you can set to slide. And that will also change the behavior. You can see though that it has slowed that down quite significantly. So maybe we won't use that. Oh, it's still pretty slow. What happened? Why did you get so slow? Back to the performance monitor. Reset. Gas geometry vex. So this is to do with collisions. You can see project hit UVs. You know what? It's that. It's not just that behavior that I did, the slide. It's the hit attributes. Turn that off. There we go. Everything has has an impact on the speed. So as long as you're aware of it, it's good. But yeah, performance monitor again. So there we go. We got some interesting behavior going on. We could drop our pop force down. Let me just do this. We could reduce that so that overall we have, slower streams running down. So there's no real reason for that to be negative 9.8. We could just dial this in to be whatever we like. Although you can see when we do that, we get particles, because they're bouncing, it's kind of like zero gravity. So they're bouncing and, look at this one. It's kind of shooting off into space. So you do have to be careful with that. Yeah, maybe we go half gravity. But we could also put a pop drag down like this. So pop drag, we'll just leave it like that. We could also increase the friction of our object. So that was on 0 friction on the pop object. So let's see what adding that to 1 does. And you can see we got back to just not doing anything. So let's turn that down 0.5, 0.1. There we go, 0.1. And we got these really straight lines. So that's not, you know, it's not that great. Let's go to our pop force and add some force or some noise to our amplitude. There we go, wiggly lines. Let's go 0.1. It's looking a bit better now. Bit more organic. What's happening on the surface is really cool as well. I like that. So we're not going to see anything that's below, you know, the water, which is good. We may also want to do this based on age. So let's go down here, use Vex expressions, and we'll do amplitude by age, or amplitude by normalized age probably is better. So here's what we're doing. We're running between 0 and 0.2 over normalized age. So it's multiplying the amplitude. So I'm just going to multiply it 0 to 1. Or maybe even 0.25 to 1, so that it's not zero noise. But it will increase. As the particles age, the noise will amp up. And in fact, instead of using normalized age, we could just do like a fit. So fit at age between 0 and 1, let's say. So that would be 24 frames. And, well, yeah, I think so. Maybe not quite 24 frames. And we'll fit that between, I don't know, 0 and 1 again. So we'll just do that for starters. See what happens. Maybe let's do 0 to 10. So we can really see it. So we should see them get really wiggly as they hit that age of 1. So you can see it's a little bit soon. Yeah, it does look maybe around 24 frames. So let's turn that up, 0 to 2. And you can check this in the geometry spreadsheet as well. So we should see as they hit 2, go to our PopNet, geometry, age. Oh, they're not hitting 2 yet. They're hitting, well, there you go. At 24, they're hitting 1. So they're halfway in between this. So actually, because this is 0 to 10, they'll be getting 5 values when they're at 1, because that's halfway between 0 and 10. So 0 and 2 halfway is 1, 0 to 10 halfway is 5. So they're getting values of 5. So if we take this back down to 1, it probably won't be as crazy. But we should start to see these ones, you know, because these ones are a bit slower on the surface, we should start to see more wiggles happening. And as they fall down, that's when we see a lot more. So that's kind of cool. It's a good way to control it. We could go back to 0 to 1 maybe and see how that impacts it. And we could do 0.25 to 1 there. The fit just gives you a little bit more control. Instead of using normalized age, which is just going to take the full age from 0 to 1, this way we can sort of clamp the age to a particular value. Okay. Cool. So that's not too bad. Now this is just on a static ship, which is great, but you know, we don't have a static ship. We have a transforming ship. So what we could do is go all the way back to our transform and apply that to our effect here. So what we end up with is this. So now we've got the feeling of it rising with these streams coming down, but really the effect is kind of, you know, it's done on a static ship and then we're sort of post-transforming that. Now let's just merge out the pops only, pop star, and we can combine that with our Oh, actually, let's just jump out one. We can combine that with our ship, although it doesn't look like it's lining up. So we need to work out what's going on there, and our water. So it looks like we have created some sort of offset here. Why is that? Transform. There's our ship. Time shift, scatter, peak, popnet. So we're starting at Let's go back and have a look. This doesn't actually start until frame 12, but it is already offset. So we're actually kind of, what do we want to do? I think what we want to do is shift these values by this. So this should be 0 because it's already in the position. So that should line up. Yeah. So that was negative 2.23. Let me just write that down. 2.23. So negative 2.23, we're going to add negative 2.23 to make that 0. And then on this end frame, go all the way back up here, I'm going to add same value, 2.23. So we're actually going to end up with 5.23 there. And that, in theory, should line up. So we're just offsetting. There we go. Sometimes you have to come up with these crazy little offsets. But it's because this ship, the transform was done from the ship at world 0. But this one, we've already got the offset baked in because we're starting at that position. So now we're just we just need to adjust that a little bit. So there's our, it's freezing because I don't have the whole simulation, but now we've got this kind of effect happening. We've got these very fine streams running down. And we can have as many or as few as we like. So, you know, we could go and, it's all just driven by this scatter here. So we've got 1,000, go 10,000 if we really wanted to. Let's do this. And because it's just solving as a static position, I mean, this is mental, it's too many. Or it's too even as well is the issue. That, you know, it might be cool to have that many. It's too even. Let's go to our scatter, turn off relax. It's a big part of it. Might look slightly better, but yeah, you know, you might want 10,000, but you don't want them all to be just evenly distributed across the whole ship. But because this is just on a static object, it gives us like quite a lot of control for this stuff. So yeah, that is a bit insane. So one thing we could do with that is we scatter our 10,000 points, but then we attribute VOP. Oh, I just realized it's 12 o'clock. Time to go. We could do a turbulent noise like this, run it into color to create some patterns within this so that we could, you know, just cull some of the points away and get these interesting sort of patches happening. If you increase the roughness, you get sort of like a lot of outlier points. So you can see as I increase the roughness, I get some just more random ones. If I don't have a lot of roughness, I get that sort of thing. So adding the roughness is a good thing with this. And then I could blast that based on color away. So you see, I still have lots of points. They're just colored at cd.x less than 1 or less than 0.1. Set to points. There you go. Let's Put our color back to white. Peak. PopNet. So now I've got these kind of clusters. Instead of points everywhere, I've got these clusters of points. Which is kind of cool. You could also, I mean, we've got this noise happening here. We could add an additional noise if you wanted to, just to create some interesting stuff happening. We could do this in a VOP as well. So just add a curl noise in there. And we'll just add it to either force or V. So you could just add it straight to the velocity. Like this. There you go. Instant wiggles. We could multiply that by the age as well. We could also make this a really high frequency. Maybe too high. High frequency, low amplitude. So that it just gives a little bit of variance. A bit of noise, but at a really sort of low amount of noise. Just to get, you know, quite a bit of variance in there. And yeah, I mean, you know, that's potentially way too wiggly, but you could vary that. Other cool thing you could do here, I'm getting carried away now, I know it's time to go, is create an ID attribute up here. So at ID equals at ptnum. And then what you could do is randomize, so we'd have to recook this, so our ID becomes present. Whoa, look at that crazy curl noise. So what we could do now, let me just bypass this for a second, make sure it's all still working. Yes, good. What we could do with this is take our ID attribute, run it through a random, pop out our amplitude here, and multiply it by this random result. So we'll get, because this is coming off ID, each one of these streams is going to have an ID, basically, because they're coming from the same point. So it's not going to be a random per point, it's going to be a random per stream. What you'll see if I plug this into a color ramp, hopefully it won't make a liar out of me. Oh, it is a bit mixed up, and you know why? That's because this creates an ID as well. The pop solver creates an ID. I don't know where that setting is, but it might be on here actually. Maybe not. What we should do is not call that ID, because ID is being used. So we'll call it PID. Something different. Is that a spaceship? Yes, it is, Rizwan. There we go. Let's turn that off again. There we go. Groovy. Alright, so there's my reminder telling me it's time to go. So we've got this random, oh, and it's off ID, so we need to bring in that PID. So much to do, so little time. There we go. So let's come out, change our ramp to infrared, and you can see I get a different color per stream. So if I was doing some kind of Technicolor rainbow ship, this would be a great way to go. But what this tells me is that, and you can see it with the noise as well, if I disconnect that, that some of the streams are wiggly and some of them aren't. Like this one is very straight and this one is not. So I get this variance over the whole thing. And I could use that in lots of different ways to vary the amount of drag, the amount of gravity. I mean, yeah, this curl noise is crazy, so we do need to turn it down. Amplitude, let's just add another 0 in there. Hopefully that won't be as bananas. But yeah, so you know, we've got this ID now per stream, which allows us to create all this kind of variance, and that is a really good way of creating, you know, these kind of, or making this feel a bit more like, you know, a natural effect rather than a very digital straight lines, you know, everything the same. You can see there's different levels of noise happening here. It also helps it feel a little bit more like Flip, which, you know, is kind of what we're going for. So I think that's working pretty well. If we come out, got our transform. It's got our base kind of ship here. Let's have a look through the camera. There we go, we can start to see that. So, you know, it's just happening all the time now. So it's just gonna, as the ship comes through, it's just revealing those points. And that's kind of okay, it seems to be working pretty well. So I think this is a really good way of getting that fine layer. We've got our flip that we did at the start, which I'll simulate. And then I'll combine those together, and next week we can have a look at what that looks like. I won't touch anything because I know that throws people off sometimes when I do things during the week and make changes, and then I don't tell you all those changes. So I won't do anything. I'll just write out what the flip was, and then we'll have a look at where we got up to next week with everything, and look at how we can improve things, and also how we can combine all this together and make it look good, and finally extend this whole effect out so that we've got a complete ocean. But I think this is a good combination of effects, and if you're struggling to do the flip component, this particle component could potentially be all that you need to do to create a really nice effect. You've got some other things that we need to do as well, and we could do them with particles too. Rizwan, the spaceship, I'll have to look up who modeled this. It was bought on CG Trader. I don't know. I'm not sure who modeled it. It was bought for another project. I'm just sort of reusing it for this, but I will try and find out who modeled this one, because it's a cool spaceship. And if you guys want to try and do the same thing, then yeah, I'll find it. It wasn't overly expensive. It was pretty cheap. I think this one doesn't have textures, but I have another one that does. Although you don't necessarily need textures for a spaceship. You can create a pretty decent procedural material, because it has so many components. It's it still looks really nice. So there we go. I think that's not too bad. Let's flip book it from 79, and I'll just let this run out. Cool. All right, guys. Well, thanks for joining me. I have to running a bit over time. I hope you guys have a good week. Hope you enjoyed the stream, and as always, I'm sure you do. I'm sure you're already subscribed, as most people here. But if you haven't, like and subscribe. And thank you very much for the support. And yeah, if you have any questions, please feel free to put them in the comments or let me know next week. And I think we'll keep working on this one next week. I think it's a cool kind of scene, and we can sort of try and get this to a finished state in a couple of weeks. Thanks, Audrey. Thank you, you too. Cool. All right, guys. Well, I'll let this flipbook play out for the rest of the stream. But have a good week, and I'll see you guys next week. See you, everybody.